I want to draw rectangles that I could use to approximate this area. If I drew vertical rectangles, will the top curve always be the same no matter where I draw that rectangle? Yeah. Okay, so like if I were to draw a rectangle right here, then basically the top curve is the parabola and the bottom curve is the line. If I were to go over here and draw a vertical rectangle, do I have the same top curve and bottom curve as I did for that first rectangle? Yes. So that's probably the way that I want to go. If I were to do horizontal rectangles, if you'll look where my arrow is right here, actually, if you drew one right here, the right side would be half of the parabola and the left side would be the other half of the parabola. If I drew a horizontal rectangle right here, the right side would be the parabola, but the left side would be this line. And if I drew a horizontal rectangle down here, the right side would be the line and the left side would be the vertical line. So I'd have to do at least 3 integrals, if not 4. I think I'd actually have to do 4 integrals. So I definitely want to go with the vertical rectangles. Okay, so my formula for vertical rectangles is top minus bottom. So what's the equation for the top curve? 9 minus x squared. And the equation for the bottom curve? X plus 1. Make sure the x plus 1 goes in parentheses because you have to subtract that entire quantity. And I need to integrate from smallest x value to biggest x value, -1 to 2. By labeling the height and the width is dx, and then the height is the top curve minus the bottom curve. I'm okay if you just wait to do that over in your work. But if it helps you, then you could say that the height of the rectangle is 9 minus x squared minus x plus 1. Okay. I don't want to, this is very easy to integrate. You just use the power rule. It ends up being 19.5 or what is that as a fraction? 39 halves? Yeah. Okay, number 2. We just have 2 equations here, so that's kind of nice. I'm going to start with the second one, y equals negative x, just because that looks a little easier to me. All right, x plus y squared equals 2. So y squared equals 2 minus x. So y equals plus or minus the square root of 2 minus x. Okay, I would suggest just graphing this in your calculator. And to graph that on your calculator, you're going to have to use 2 y equals. In y1, you'll need to do the square root of 2 minus x. And in y2, you'll need to do the negative square root of 2 minus x. And then you can transfer that to the graph. And this would probably be a good time to practice finding points of intersection. Okay, and sure enough, it was a sidewise parabola. It's what we should have expected. You can use the table if you want to figure out that point of intersection, but they're not always going to be whole numbers. So under F5, intersect. Now, I want you to move to the right of one of your points of intersection before you hit enter. I just did F5 and intersect. All right, so first curve, I'm going to hit enter. it automatically bumps you to another curve. But remember, we've got 3 different curves in here. This one happens to be the correct one for that top point of intersection. So I'm going to hit enter again. And then lower bound just means I'm to the left of the point of intersection. So I am. So I can hit enter. And upper bound means I need to be to the right of that point of intersection. So it's the point -2, 2. I'm sorry, I thought I misspoke myself. You actually want to start to the left of your point of intersection. Okay, so to find the other point of intersection, I need to go to F5 again and number 5. And just make sure you're to the left of that second point of intersection. Hit enter. All right, now when I hit enter, it bumped me up to the wrong curve. Your up and down arrows will move you between the 2 curves. So if you down arrow, now you're down on that negative square root equation. So that's my second curve. Lower bound is to the left, enter, and then move over to the right for upper bound. Okay, so 1, -1. If you're stuck on the second curve, hit the up and down arrows. Okay, so this is what your graph looks like. All right, do I want to use a vertical rectangle or do I want to use a horizontal rectangle? Good, I want to use a horizontal rectangle. Just to play devil's advocate, if I do vertical rectangles, okay guys, settle down please. If I do vertical rectangles, then over here on the left side, I'm going to have the parabola minus the line, but then I'm going to have the parabola minus the parabola for that part right there. So I want to use horizontal rectangles because anywhere I draw a horizontal line, the right side is always going to be the parabola and the left side is always going to be my line. All right, so I'm going to integrate. Right side is, okay, now if I'm using horizontal rectangles, then my width is dy, so I have to integrate with respect to y. So what do I need to solve my equations for? X. So x equals 2 minus y squared, and x equals -y. So right side minus left side is 2 minus y squared minus a -y. And then what will I integrate between? What are my limits of integration? -1 to 2. All right, now this is one that you can use your calculator on, and this is very strange, but it ends up being the exact same area as the one on the front. It's just that I've taken basically the same parabola and the same line, and I've kind of shifted it somewhere else. So you really need to solve this on the home screen just using your integration. All right, start graphing number 3 on your calculator. Okay, this is not a perfect graph, but you kind of get the picture. I don't know if my 2 humps, I think that bottom hump needs to come below the x-axis, but that's okay. Okay, that's what we need to find out is these points of intersection. All right, so let me get this into my calculator. Okay, the first thing I want to do is I want to find the leftmost point of intersection. So if you're having trouble with the points of intersection, follow along as I go. Whoa, where'd it go? Okay. All right, so F5, 5. Whatever curve you land on, just move to the left of that point of intersection and hit enter. This one's going to be easier because there are only 2 curves on this one, so there's no toggling between the different curves. All right, the second curve, that is my second curve. Lower bound, I am to the left, so I'm going to hit enter, and then I need to right arrow until I'm to the right. Okay, I get this big long decimal. Now remember that your final answer has to be accurate to 3 decimal places. So if I integrate with the limit of integration as negative 2.121, chances are my final answer is not going to be accurate to 3 decimal places. Now right now, the calculator has stored this value in the variable xc. So I need to go to my home screen and I need to transfer that store to a single variable. Let's transfer it to y. So what I'm going to do is I'm going to go immediately to the home screen and I'm going to type in xc. So I'm going to have to do x and then alpha c. And I'm going to store that, it's the STO button, in y. I don't know why you can't keep it in xc, but it doesn't work very well. It kind of screws things up. Right, because I'm going to have another xc as soon as I find that other point of intersection. That's the reason. All right, on my paper, however, I'm going to kind of jot down that that point of intersection is the x value is negative 2.121, just so that as much, you need to write down everything that happens throughout this process. Okay, so that first x value is stored in y. Okay, go back to your graph. This point of intersection in the middle is 0, 3. Okay, I'm just going to tell you that. You could have found it. Okay, find that final point of intersection. So F5, 5. First curve, enter. Second curve, enter. I am lower bound or left, enter. Whoops. Move over to the right, enter. Okay, so the second point of intersection is just the positive of that. Yeah, you could use positive and negative y if you want to, or we can go to our home screen and take xc and store it in, say, z. Okay, so let's go back and... Do I want to use horizontal or vertical rectangles here? Definitely vertical. And I have I didn't really talk about this, but I actually have 2 parts of this graph that are bounded by the 2 equations. So I have 2 areas that I'm going to need to find. Okay, so the first hump right here, top minus bottom is what? Y cubed minus 5x plus 3 minus negative 1/2 x plus 3. Sorry, I should have put x cubed. Yeah, I'm just crazy. Sorry, that should be x cubed minus 5x plus 3. Okay, and that those limits of integration are from y to 0. X equals 0. And you really need to say somewhere that y equals the negative 2 point, whatever, 1, 2, 1. Okay. And z is positive 2.121. Okay, so my second little hump right here, top minus bottom, is going to be negative 1/2 x plus 3 minus the x cubed minus 5x plus 3. And that is going to be from 0 to z. And then you get to type all of that fun stuff into your calculator. And when you're on your home screen, when you're entering this, like when you enter that first integral, then you just do comma x, comma y, comma 0, and that'll integrate using those stored y values, or those stored values for y and z.